1/5, 2/5, 3/5, 4/5, 1. Or 0.2s if you like. Put in 1 for x and see what you get for y. When x is 1, what's y? 1. So graph that point, graph that ordered pair, 1, 1. That is on our graph. We're going to graph y equals 1 over x. And I'm going to graph point 1, 1. Now I'm going to check and see what happens when x is equal to 2. Oh, 1/2. 2 gives you 1/2. This is a reciprocal. We're putting a 2 in for x. It's not 2 divided by 1. It's 1 divided by 2. That is 1/2. Right there. Notice these are reciprocals of one another. And they always will be. 1 over x is considered to be a reciprocal. What happens when x is 3? 1/3. What's decimals that? 0.33333. Since this is 0.2 and this is 0.4, we're in between those two, a little closer to the top than to the middle. But it's going to be hard to draw that anyway. There you go. What about 4? 4 goes with 1 over 4, which is 0.25, which is just a little tiny bit lower than this one. This one's 0.33. This one's 0.25. It's just barely above the line. Now I'm going to do these fractions, and I want you to remember that these are reciprocals that we're going to get. What is this point right here for x? What's its value for x right there? 4/5. And when you take 1 over 4/5, you multiply by the reciprocal and get the reciprocal. That's 5 over 4. Is that clear? You're taking 1 and dividing by 4/5, and you get 5 over 4. So, 5 over 4, what's that? 1.25, or 1 1/4. It's right there. What about this value for x right there? What's this value for x? 3 over 5. What's the reciprocal of 3 over 5? 5 over 3, which is 1 2/3. It helps to make mixed numbers in this case. So 1 2/3 is 1, and 2/3 about 1.6, 1.7. Right there. What is this number right here? For x, right there. What's that one? 2 over 5. And the reciprocal? 5 over 2, which is? 2.5. 2.5 right there. Now this one is? 1/5. What's the reciprocal? 5 over 1, which goes, here's 3, 4, 5. It's way up here. One of the things that we're going to look at a lot today is a thing called asymptotes. This number, no matter how big I make it, it's going to keep, if I pick a number bigger than this, let's say 100. What happens when you put 1 over 100? 1 divided by 100? 1 divided by 100. 0.01. Yes? 100, way out here, gives you something just a little tiny bit above the line. What if I put in 1,000? 0.0001. And 10,000 is 0.0001. And 1 million is 0.000001. I never quite get to 0. That's why it's called an asymptote. This line, by the way, has a name. What is it? This is the x-axis, but here's the important thing. The x-axis has the equation y equals 0. Y is equal to 0 on this line. Yeah?
Can you go to the counselor? All right, thank you. I'm sorry.
See how important it is, maybe at the end of the period. It's never an emergency. All right. Can everybody see that you're getting closer and closer and closer to this line? And this line is where y is equal to 0. When x gets very large, y gets very small, or close to 0. That's called end behavior. And it's going to be really important with what we're doing today. When you pick really large x's, we get closer and closer and closer to this line. Now, as we pick very small x's, like 1/100th, do y'all understand that that's read 1/100th here? What's the reciprocal of 1/100th?
100 over 1.
100 over 1. So if I put in x is 0.01, I get 100 for y, don't I? When x gets very small, y gets very, very large. This line is called the y-axis. What's its equation?
It's equal to
The y-axis, its equation is x equals 0. As x gets very, very small, y gets very large. As x gets close to 0, we say as x approaches 0. Now, does everyone understand that I could approach 0 from this way or from this way?
Yeah.
If I approach 0 from the right, then I say that I'm approaching it from the positive side. I'm picking numbers that are just a little tiny bit bigger than 0. Is that clear? Y'all understand that x can never be exactly 0? Yes? Because you can't divide by 0? So this line is a taboo. This line is an asymptote because it basically is not x equals 0, it's x is not equal to 0. I can never cross this line, but I can get really close to it. I'm going to get really close to that asymptotal line. Now look what happens when you do the negatives. Put in -1 for x. What do we get for y when x is -1? -1. And when x is -2? -1/2. This looks like it's going to be symmetric. It's going to approach this one. And look what happens when I approach x. When I approach 0 from the other side, I get negative infinity.
Well, it's kind of like that thing we did earlier.
How we doing? Got 'em? This is like tangent, by the way. Tangent lines do that as well. Tangent lines have asymptotes at pi over 2 and 3 pi over 2 and so on. Now for the big idea, and this isn't easy. Remember what happened when we took a graph and, you guys remember what this graph looks like? Y equals x squared? What is it?
Parabola?
It's a parabola. It's a standard shaped, vase shaped parabola at 0, 0. Now what happened when I took that equation and I said y equals x minus 2 squared?
It'll be shifted.
It's shifted, horizontal shift, right? Or left? Which way does it move this graph? To the right, because we need to get a 0, don't we? All right, watch this. Same idea. See how I have 1 over x? What if I graph y equals 1 over x minus 2? What's my taboo value for x? What can x never be equal to?
0.
0 is not a problem. 2 is the problem.
Oh.
Isn't 2 the problem?
Can we make 0? Yeah.
Exactly. I can't divide by 0. I can divide by negative 2. 0 is not a problem. 2 is the problem now. So what did I do? I took this line, this asymptote, and moved it over to right here, didn't I?
So if it was x minus 3, you could have a positive 3.
Right. What effect did it have on my graph? Well, it moved it over.
So we're starting off with
Doesn't it go here and gets closer here
a... Yeah.
and gets closer down here? That's it. It just got moved over. Got it? All right.